We are solving Mechanical Engineering Paper 1 of year 2025 of Civil Services Mains Exam. Question number 4C2 is: in a 4-cylinder symmetrical engine, the intermediate cranks are at 90 degree and each has a reciprocating mass of 500 kg. The engine is in complete primary balance. The center distance between intermediate cranks is 600 mm and between extreme crank is 1800 mm. The length of the connecting rods and cranks are 800 mm and 200 mm respectively. Determine the masses fixed to the extreme cranks along with their relative angular positions. If the engine speed is 150 rpm, find the magnitude of secondary unbalanced forces. So here, this is your primary balancing diagram. This is first crank, this is second crank, this is third crank, this is third crank, this is fourth crank. So as the angle between second and intermediate crank is 90 degrees, so 2 is at 0 degree and 3 will be at 90 degree. And masses of each of the 2 and 3 is same, so that is 500 kg. Length of connecting rod is 800 mm or 0.8 meter. Radius of crank is given as 0.2 meter or 400 mm. So n is 0.8 by 0.2, 4, or 800 by 200, that is 4. The ratio of connecting rod to crank is 4. So now from this diagram we can find out M2, R2, L2, taking 1 as reference point. So M2 is 500, radius of crank is 0.2, and this distance is 0.6 meter. Because total is 1.8 meter, this is 1.6, this is symmetric, this is 0.6, this is 0.6. Total is 1.8, this is 0.6, this will be 0.6, this will be 0.6, so this is 0.6. So M2, R2, L2, or we can say the moment of the primary force caused by 2 divided by angular speed square is your 60, taking 1 as reference. Similarly, M3, R3, L3 will be your 500 into 0.2 into 1.2. So this is now 1.2. R is same for this and this, and is same for this and this. So that will be 120. For its mass is M4. So R is same for all the cylinders or all the cranks. So M4 into 0.2 and this distance is 1.8, that is 0.36 ampere. So now if we draw the primary couple diagram, this is your couple. This is the indication of couple, different couples. So here 2 is there, 2 is at 0 degree, 3 is at 90 degree. So 1 is not causing any couple because it is a reference plane. So this will be your fourth. So by graphical method you can draw this, and then measure this, or add and measure this angle. Or by analytical method we have to take the cos component of it, cos 0, and cos component of it, cos 90. This is at 0 degree, this is at 90 degree, and sine component of it, and sine component of it. This is 0, this is 90, and square and add. So it will be cos 0 will be 1, so it will be 60 square, or this is 120 square, or from this we can have 60 square plus 20 square. 120 square is equal to 0.6 M4, or M4 from this we get 372.67 kg. And to find out this angle, we will take this as minus 120. We will find minus 120 and take this as minus 60. Find out this angle. So this is in this side and this is up. So both will take negative. Okay. or we'll find out this angle and subtract 360 from it. Okay, so this will leave 243.4 degrees. So now if we take this as reference plane, we can find out M1 same way, because it is symmetry, so it will be having same value, that is 372.67, and find out theta 1, that is 206.6. Or other way, when we have found out this M4, we can draw the force diagram also. This will be 2, this is 3, this is again this is your 4, and this is 1. We can measure this and measure this angle. So either of the methods can be selected. So from both the methods, M4 will be 372.67 and M1 will also be 372.67, and theta 4 will be your 243.4 degree, and theta 1 is your 206.6 degree. So these are the values of masses and their relative position. So now for the second part, secondary cranks. So this is the secondary crank diagram. So in secondary cranks, all angles are doubled. So this angle we have found 243.4. So its double is 486.8, or we can say it is we subtracted from 360, it will be 126.8. And similarly this double will be 413.2, or we can say it is 53.2 degrees. So and this is the for keeping this two in the same position, this will be double also. Previously it was 90 for primary crank, for secondary crank it is 180. And omega is 2 pi n by 60, so it will be n is at 150 rpm, so it will be 15.7 Newton/meter. So we have to find out the secondary unbalanced force. So secondary unbalanced force can be found like this. This is the magnitude of 1 is we have, or we can have MR we will draw. Then we will draw this M1R1, and then we draw this M2R2, then we draw M3R3, and then we draw M4R4. So this will represent unbalanced secondary force. The value of M1R1, M1 is known, R1 is known, so it is known. Value of M3R3 and M2R2 is same, so we will come back to previous question. Now this is your M4R4. So now we have to show only this M1R1 and M4R4. So M1 is your 372.67, 0.2. R1 is 0.2, and this angle is 53.2. So its vertical component is sine, and its vertical component is also sine 126 degrees. So this will give the answer. Okay. So that is 7363.1088. This will, or we can take the horizontal component of all the masses. So that is 372.67 cos. This is 372.67 cos 126, and here we have 500 cos 0 and 500 cos 180 or 3. Similarly, we have sine component, then here and add. Okay, so here it will also be square. Okay, so either of the method can be selected. Either graphically is easy, because just we have to draw M1R1, M2R2, M3R3, M4R4. So after drawing M1R1, we can take sine component of it, and after drawing M4R4, we can take sine component and add them.